How are secant lines and the average rate of change related? Now let's look at it and see. So think back, what's a secant line? What does a secant mean? A secant line is a line passing through 2 points on a curve. So looking at our graph down here, this would be a secant line, this would be a secant line, this would be a secant line, this would not. It only passes through 1 point. This would be a secant line. So a secant line is a line that passes through 2 points of a curve. What is the average rate of change? Well, the average rate of change is the slope of that secant line. Because remember, we just said the average rate of change is the slope between the 2 points. Well, we have 2 points for our secant line. So the average rate of change is the slope of the secant line. Let's look at this one. The graph of a function f is shown. Here it is in red. Sketch on the graph a secant line whose slope represents the average rate of change. So that's going to be our slope, that's our secant line, over the interval 2, 6. Now we have our points. Then compute this average rate of change. All right, let's see what we can do here. So 2 is our first x. So I'm going to put a dot right here. And 6 is our second x. Well, 6 is going to be right here. So I'm going to put my dot right there. So it's saying to draw the line. All right, we can do that. I didn't do it very well. I hope your line looks a little bit better than mine. And it's asking us to compute the average rate of change. So that means we need to know the change in y over the change in x. So we're going to have to estimate this. Let's do the best that we can. This looks like it's a little bit past the halfway mark. So I'm going to call that 0.2. And for the x coordinate, let's say 1.6 for the y coordinate. And then for this one right here, looks like for the x coordinate, we can say 6. And for the y coordinate, that's right on the 1. So there we go. So now let's calculate this. So we need our y value from our second x, that's 1, minus our y value from our first x, that's 1.6, over our second x, that's 6, minus our first x, that's 2. So 1 minus 1.6 gives us negative 0.6, and 6 minus 2 gives us 4. So if we divide, we get approximately negative 0.15. Well, we knew it was going to be negative because this is a decreasing, it's going down. The slope is going down here. So we have our negative, so that looks pretty good. Part B, is the average rate of change over 0, 3 positive or negative? Well, let's check it and see. So I'll make this one red. So 0, 3. So that means 0 is our first x. So that's right here. And 3 is our second x. So that's right here. So if I draw a line to connect these 2 points, best as I can, there we go. It looks like that is going to have a positive slope, which means it's going to be a positive rate of change. So it says, which interval gives a larger average rate of change? Well, the average rate of change is the slope. So this is asking us which one has a bigger slope. What do you think? Is the blue slope bigger or is the red slope bigger? I'm going to say 0, 3. It looks more steep and it is positive, whereas the slope between 2 and 6 is negative. So a positive value is larger than a negative value, and it also looks like it has much more steepness. So which interval gives the larger average rate of change? I'm going to say 0 to 3 for that one.